In your Unit 4 note packet, turn to your 4.3 Combining Like Term note sheet. We are going to look for those look-alike terms. And another way to say look-alike are find things that are similar. And we're going to stay calm as we work through this lesson on combining like terms. Our goal is 4.3. I can recognize and combine like terms. Go ahead and underline combine like terms. Recognize means when you're given an expression, you can see right away when you have terms that go together. And then you know how to bring those terms to get together, how to combine them. That's what this goal is saying. This slide you do not need to write down in your notes. It's just the vocabulary. And you heard this last year, and you may or may not remember all parts of it, and that's okay. And you may or may not remember all parts of it after we go over it today, and that's okay. There are many parts that make up an expression. First of all, it's an expression because we have numbers, we have symbols, and we have operations. So there are 4 parts of this expression that have specific names. They're called terms. Terms are a number, a variable, or product of both that gets added or subtracted from each other. And then within terms, you have more special names like coefficient. Remember, when we are showing multiplication, we want to use invisible multiplication, and we always want to bring the number before the variable. That's because it has a special name. It's called a coefficient. Then you also have terms that don't have a variable being multiplied to them, and they have a special name. They're called constants. Let's actually review how we combined like terms last year. Let's bring back some of our previous knowledge. You were given an expression like this. There's nothing you need to write in your notes yet. And we were supposed to look at that and say, hey, I can combine some things together. So let's put pictures with this expression. Let's say A is for apple, B is for banana. So my A that starts right here represents 1 apple. I have 3 bananas. I'm adding 4 more bananas, and then I have 2 apples. Do you see how my picture expression down here matches my algebraic expression above? One thing to point out here, do you notice how when I said an apple, that represented 1 apple? I don't need to say 1A. I can just say A and it represents 1. There's that invisible 1 in front of a variable all the time because of that identity property of multiplication where you're taking 1 times any number, you're going to get that number. So we have 1 apple plus 3 bananas plus 4 bananas plus 2 apples. There are some items here that are the same that we can combine together. So I'm going to start by looking and saying I don't have any numbers just on their own. There are no constants in this expression. Let's start by giving shapes to our terms that are similar, or they're look-alike terms. So we have an apple here. I'm going to box that in, and I'm going to box in the plus 2 more because it's a positive 2. Then I have my bananas. So let's give them a different shape because I wouldn't combine them with the apples. And I'm going to always bring in the operation in front of it, the plus or the minus. So now I can combine my apples together. Altogether, how many apples do I have? 3 apples. And altogether, how many bananas do I have? 7 bananas. So we just simplified the expression using combining like terms. Find that first chunk in your notes. Do you see how you have 4 blank lines? Look-alike terms have the same variable, same exponent. Go ahead and fill those blue words and red words in on your lines. I'm giving you 3 examples below. We have 7a and negative 3a. Are those look-alike terms? Could we combine them together if we needed to? Do they have the same variable? Yep, they both have an a. Do they have the same exponent? Well, there isn't an exponent showing, but really there's that invisible 1 up there, a to the first power, because that would just be a. So yes, they are like terms. They meet the definition of a look-alike term. In your notes, go ahead and draw an arrow and write like terms below that first example. Next, negative 4x squared and 12x squared. Are those look-alike terms? Could we combine them together if we needed to, like my apple and banana problem before? Well, do they have the same variable? Yes, they have x and x. Do they have the same exponent? Yes, they're both being squared. The x's are both being squared. These are look-alike terms. Go ahead and draw the arrow and write like terms underneath that second example. What do you think about the last one there? 6xy squared and 5xy squared. Do they have the same variables? Yes, they do. Do they have the same exponents? Well, let's talk here. Here I just have an x. Here I just have an x. So yes, they match the definition of a lookalike term. Here I have a y squared. Here I have a y squared. Yes, they match the definition of a lookalike term. Altogether, 6xy squared can be combined with 5xy squared. They are lookalike terms. They have the same variables, the same exponents. Go ahead and write that in your notes. Are these like or unlike, and why? We just went over what lookalike or like terms are. Find the second chunk in your notes. Our first example is 3x squared and 4xx. Are those like terms? Do they look alike? Remember, x squared, that's the same as x times x, and that's what this part right here is showing. So even though there isn't an exponent up there, we could write this as 4x squared. Therefore, they are like terms. So let's write like, and then our reasoning is they both have x squared. X squared is the same as x times x. Fill that in your notes. The next example is 2a cubed and negative 5a cubed. Now, according to be like terms, they have to have the same variable, same exponent. Do they? They both have an a cubed. Fill that one in your notes. Look at the last example, negative 4x, x, y, y. There's a lot of invisible multiplication in there, isn't there? And negative 6 times x times y times x times y. Now, don't forget about a very important property that we talked about when we were working on translating algebraic expressions, and that's the commutative property, right? Where you can change the order of what you're multiplying and isn't going to change the product. Here I have two x's, they're being multiplied. Over here, do I have two x's that are being multiplied? Yes. Here I have two y's that are being multiplied. Over here, do I have two y's that are being multiplied? Yes. Do they have the same variable? Do they have the same exponent? They sure do, so they are like. Even though in the second term there with negative 6xy, the x's and y's are in a different pattern, it doesn't matter. We could rearrange them because of commutative property. Therefore, they are like terms. That can be a little tricky, can't it? Yeah, math is a language, remember, and we're constantly working on understanding that language. Turn to the back of your 4.3 notes. Find examples. Write down example 1. We need to simplify the expression by combining like terms. 3x plus x, plus 4 plus 2x. Start by looking at the terms. Are there any constants? A number just on its own? Yes, the 4 is a constant. Go ahead and underline the constant 4 and include the operation in front of it because that tells you that this is a positive 4 or that you're adding 4. Are there any other constants? No, so let's go to the first term, which is 3x. Are there any terms that I can combine with 3x? Meaning they have the same variable, so an x, the same exponent. Now this term right here, it does have an exponent in it, it's just invisible. 3x to the first power is the same as 3x. I see a term right here, right next door, that is just an x, has the same variable, same exponent. So I'm going to give it the same shape. And I'm going to include the plus in front of it because that tells me that with 3x, I'm adding another x. Is there another term that I can combine with those two? 2x, same variable, same exponent. I'm going to include the plus in front of it, and I'm going to put the same shape around it. So now I can see that I'm going to combine my rectangles together. 3x plus x, that's 4x. I'm adding 2 more x's. That's 6x plus 4. Now, remember, math is a language, and we're always working on learning the language, and sometimes there's so much to remember with it. There's a professional way to write our answer. We did not talk about this as 6th graders last year. Professionally, when we are simplifying an expression where we're combining like terms, we want to, from left to right, have the highest exponent going to lowest, have the expression in alphabetical order, and have that constant coming last. In this expression, Each term just has an invisible 1 as an exponent. There's no other letters outside of x, so we have it going in alphabetical order. Our constant is coming last. So we wrote this in the professional way. What I want you to do is, in the left-hand column on the back of your notes, underneath the question, how do you combine like terms, write the 3 steps for the professional way. Pause the video. Let's do example 2. Write this one down. Y minus 2x plus 3y plus y. Let's go to the first term, which is y. Can we take this y and combine it with any other term? Remember, we can combine like terms when they have the same variable, same exponent. I see some, so I'm going to give y the shape of a circle. Plus 3y, I can combine my 2 blue circles together. Plus this term over here is 1y, or I can say just y. I can combine that with my 2 blue circles. Minus 2x, this 2x, can I combine it with anything? No. So I'm going to give it a different shape, or you can choose not to put a shape around it at all. So if we go ahead and we combined our like terms, we have y plus 3y, that would give me 4y, plus another y, that would give me 5y, minus 2x. Now remember, there's a professional way to write our simplified expression when we're combining like terms. Highest exponent to lowest. Our exponents here are both 1, the invisible 1, y to the first power, x to the first power. Alphabetical order. Here I have a y coming first. Alphabetically, x should come first. I need to do a little flipping. I don't have any constants in this problem, so my final answer should be, this is a minus 2x, so it's going to be minus 2x plus 5y. If there's anything that you see in front of you that you're questioning, how did you get that? In the left-hand column, to the left of that example, go ahead and write your question down quickly so you can ask when we come back together. Pause the video if you need to. Example 3, x squared plus 2x squared plus 5 plus x plus 3x. Are there any constants in this problem? There is a constant. We have a 5. It's a positive 5, a plus 5. I'm going to underline the plus in front of it with the 5. Look at your first term, x squared. Do you see another term that has x squared in it? Yes, so I'm going to give x squared a shape. I see the neighboring term is 2x squared. I'm going to give that the same shape, and I'm going to include the plus in front of it because this plus tells me it's a positive 2x squared. I'm going to add 2x squared. I have 2 terms left, and they are terms that I can combine. 1x, which I can just call x, and 3x, right? They have the same variable, same exponent, same power. Now let's go ahead and let's combine our like shapes here. We have x squared plus 2x squared. How many x squareds do I have? 3x squared, plus my constant, which is 5, plus I have 1x or x plus 3x. How many x's do I have? 4x. Now we want to write our final answer, and in the professional way. We want to go highest exponent to lowest. My highest exponent is the squared, so that term should come first. We want to make sure that we're going in alphabetical order and our constant is last. Now we have 3x squared. We know that should come first, but here I have 4x, which is the same as 4x to the first power. That should come second. And something that stands out is your constant should come last. So if your constant comes last, your 4x has to come second. That can be a little tricky, can't it? But the more we practice this language of math, the better we're going to get. If you have a question about anything you see in front of you, write your question down next to example 3 in the left-hand column. If not, let's go to problem 4. We have negative 2y squared minus 3x minus x plus 2y minus y squared. Remember, subtraction signs are negative signs. Addition signs are positive signs. Are there any constants in this expression? No. Go to the first term. You have take away 2y squared. Is there any other y squared in this expression? Yes, so I'm going to give y squared terms a circle. So we want to make sure we include the plus or minus in front of the term. And way at the end of the expression, I see my other y squared. So I have minus 2y squared minus y squared. My next term is a minus 3x. Are there any other terms that have x in them? Yes, so I'm going to give the term with x in it the rectangle. 3x and my x right here, I can combine them together. My last term is a 2y. Are there any other terms that I can combine with that? Nope. So this time I'm just going to leave it and not give it a shape. Let's combine what we have. We have minus 2y squared and we're taking away a y squared. It's like a negative 2 minus 1. Remember, there's that invisible 1 in front of every variable. Negative 2, take away 1. Use your calculator if you're not sure. That would give you negative 3. So that's a negative 3y squared. Negative 3x, you're taking away an x, meaning you're moving further left on the number line. So negative 3x minus x gives you minus 4x plus 2y, because I couldn't combine my 2y with anything else. Now, is this simplified expression written in the professional way? Does it have the highest exponent coming first? Yes, y squared has the highest exponent. Is it going in alphabetical order? It is, because after I put my term with the highest exponent, if I cover that up, I'm left with an x and a y. X comes before y in the alphabet. That's why minus 4x is coming next. I don't have a constant in this expression, so I don't have to worry about that part. Any question you have about the simplified expression for number 4, go ahead and write it in the left-hand column. Problem 5, we're going to simplify the expression by combining like terms. Write it down. We have x cubed plus 2x squared plus 7 plus 3x cubed minus x squared minus 3. Pause the video. You simplify this expression by combining like terms, and then come back and compare your answer with mine. Pause the video. When I simplified this, I get 4x cubed plus x squared plus 4. How'd you do? Remember that professional way to write it. Highest exponent to lowest, I have the 3, the exponent 3, and then exponent 2, so it's going highest to lowest. Alphabetical order, I only have x's, so that works out nicely. Constant coming last. Example 6, x squared y plus 2x squared y minus 7 plus 3x minus 5x squared y minus 3 minus 8x. Dear goodness, this is long. Pause the video and see if you can find the look-alike terms. Get them identified, come back and compare your answer with mine. Pause the video. All right, I have 2 constants. I have 3 terms that have x squared y, and I have 2 terms that have x. Pause the video again. See if you can combine these like terms and get your answer to match mine. Pause the video. When I went x squared y and I combined it with 2x squared y, that gave me 3, right? X squared y. But now over here I'm taking away 5 x squared y. So it's like 3 minus 5, that's a negative 2 x squared y. Just keep that part tagged on with it. Negative 7 minus 3. You're at negative 7, you're taking 3 steps further left, that's going to bring you to negative 10. And then you have 3x, it's a positive 3x, and you're taking away 8 x's. That's going to leave you with a negative 5x. Is this written in the professional way? No. Maybe you notice that right away when you hit play again. Highest exponent to lowest, alphabetical order, and constant last. Professional way would look like this. Any questions on what you see in front of you, go ahead and on the left-hand side of your notes, write your question down so that when we come back together, you can ask it.